This conference will now be recorded.
Good morning, everybody. So let's continue our previous session discussion. So I want to talk about a DB polling operation in DBAdapter. We already discussed about an example. I want to read the data from a database table and do some data processing and insert the data into a target table, something like this. If you see my screen, this is my source table. This table contains bunch of records. From this table, my SOA service will read the data. From this table, my SOA service will read the data. We are using an operation called DB polling. Okay, for that I am using DBAdapter DB polling operation. From here, my Bpel process will accept the request data and do some data processing, and finally the result data I want to insert into target table. So this is my target table. Okay, student result is my target table. In this I want to insert student ID, student name, total marks and grade. Okay, so English plus Hindi plus maths becomes total marks. So out of 300, let's assume each subject is for 100 marks. Okay, out of 300 marks, how many total marks we student got? The total marks you need to insert here, and you need to calculate the grade. Let's assume A grade, B grade, C grade. If the total marks is about 200 A grade, between 100 and 200, let's say B grade, and less than 100, let's say C grade, something like that. I just want to give some grading logic here. Okay, so this is how I want to do the example. So guys, already we have this table. This table is already we created this table for the other example, right? Practice adapters example, we used this table, the same table I want to continue. And for the current example, this is the new table I want to create. Okay, it's very simple. Just go to your SQL worksheet, database. No, let's go to tools. Here you can see SQL worksheet. Okay, SQL worksheet. You can also use the shortcut Alt plus F10. Okay, and I want to use my DB connection. This is our DB connection we created in the previous session. Say okay. I will get an SQL worksheet. Let the J developer open the SQL worksheet. Okay, and this is the script to create the table. Let me create a table. Okay, table got created. So now you have two tables. Select star from stu underscore info is the first table. Just run the select statement. See the result. See the result. My table contains 22 records. Okay, and then select star from stu underscore result. This table has no data. There is no content at all. Okay, done. So now what we do, let's create a new SOA project to achieve the requirement. So this is our requirement, right? This is our requirement. To achieve this requirement, I want a new SOA project. Okay, let me create a new SOA project. I will name it as student calculate student result or something like calculate student grade, something like that. Provide a new naming convention. Okay, I will say calculate student grade. Okay, calculate student grade is my project name. Just say finish. Done. And here save everything. Save everything. Now this is the project. So here what I want to do, I want to configure two DB adapters. First DB adapter read the data from student info table. Second DBAdapter inserts the data into student result, right? Student result table. Okay, done. So now let me configure DBAdapter. DBAdapter as a service component. See this. I want to configure DBAdapter as a service component. Provide some naming convention. I will say student info DB polling. Some convention. Okay. Use the DB connection. If you don't see the DB connection in the drop-down list, you can browse it. We already have a DB connection. Browse it. Say okay. Okay, got the connection, and we need to provide the JNDA name, database adapter JNDA name. We already have a database adapter JNDA name, right? Do you remember what is it? We created the JNDA name. Anyone remember the name? If you don't remember, what we can do, one option is you can go to WebLogic console. Sorry, not here. You should go to WebLogic console. Okay. Or another way is you already have a JCF file, right? In the previous example, let me go to the where is it? Yeah. Open my code. I will open my code. Practice adapters. So here we have DBAdapter, right? If I open this in a notepad file, JCF file. If I open the JCF file in notepad, you can see the JNDA. Copy the JNDA. Provide the JNDA in this adapter. I mean, we should not provide any spelling mistakes, and this is case sensitive. Capital, small letters, whatever we have, exactly we need to follow. Okay, we should not change even one character. So this is runtime connection. We discussed that in the last session. Above connection is a design time connection. This is design time connection, and the below one is a runtime connection. Okay, click next. Now here observe guys, we want to read the data. We want to go for a polling operation. So this is the polling operation. Poll for new or changed records in a table. So this is the polling operation we need to perform. Okay, select this operation, click next. Now in step number 4, it is asking to select the table. From which table you want to poll the data. Polling is nothing but reading the data. Okay, polling is something like a self-start operation, like your file read adapter. This DBAdapter polling operation also a self-start adapter. It will start by its own based on the polling frequency. You can set the polling frequency exactly like your file adapter. We did a file adapter example in the previous session, right? Same like the polling frequency we can set in DBAdapter, and it will read the data from a table. Here it is asking, what is your source table? In this screen, we need to say which table we want to read the data. Okay, it's very simple. Just go for import tables. Okay, and browse table. So what is our table name? Student underscore info. This is my table. I want to read the data from this table. Simply click next. I mean, I just selected the table. So here we are doing two things. One is we are telling the adapter this is our source table, and second thing, we are trying to get the structure of the table. So definition of the table. Okay. So based on the definition of the table, our XSD and WSDL will be constructed. Just say okay. Right. So we are able to successfully browse the table structure. We informed the DBAdapter this is our source table, and we are also informing the adapter this is the structure of the table. Okay. Click next. So it is asking there is no primary key. There is no primary key in your table. That's okay. Let's assume student ID as our primary key. Okay. Click next. So we are not using any relational tables as of now. So simply go to next screen. So now it is asking attribute filtering. So anything, I mean, these are all the fields in the table. Are we don't want to read anything? In that case, you can skip something. Okay, suppose maths, marks, I don't want to read. You can just simply uncheck this one. Okay, whatever field you don't want, you can simply uncheck that field. Okay, let's say as of now I want all the fields. Okay, say next. So this is important screen, guys. We have several options to perform polling operation. The first two operations are very important. The first two patterns. One is delete the row that were red. See, this is past tense. Delete the rows that were red. Okay. So whatever your adapter, once it reads the data from the table, delete the row. Okay. And the second option is update a field in the table. So we'll talk about this little bit later. In this example, I want to talk about the first pattern. So what is this pattern? If the adapter reads the record, delete the record to avoid duplicate processing, guys. If it is in the table without deleting, so we should give a clue to the adapter. I mean, suppose let's assume my table contain 100 records. My adapter read 10 records and 90 records were not processed. Okay, in the next polling, second attempt, because it's a self-start adapter, right? It will start by its own. So let's assume our polling frequency is 10 seconds. So first my adapter reads first 10 records. 10 records were processed. And if I don't delete them, that means my table contains all 100 records. Out of 100 records, 10 records were processed. 90 records were not processed. In that case, in the second attempt, I mean after 10 seconds, my DBAdapter again tried to read the data from the table. Okay, at that time, adapter has no clue what are the records processed and what are the records not processed, correct? So to avoid that confusion, what we are doing, we are selecting a pattern called delete pattern. I mean, if the data read by the adapter successfully without errors, delete the data from the table. Of course, this is not the only pattern. We have other patterns as well. So let me start with this pattern. Okay, right. So select this operation, delete the rows that were read. Click next. So this is also one of the important screen, guys. Here you can observe the SQL query generated. What is the SQL query we are trying to execute? Okay. See, let me paste this in a notepad file. It is executing two statements. Your DBAdapter is executing two statements. Okay. First one is a polling SQL, and second one is after read SQL. After adapter read the data, what is the action we want to perform? The first one is just simply select query, but the second one is a delete query. Delete query. So once record read by the adapter, data read by the adapter, delete the data. Okay. Right. It's just, I mean, we cannot edit this. We are not going to edit this query. It's not editable here. Okay, but for your understanding, I'm just showing you the queries what are generated by this adapter. Okay, right. So coming to the polling frequency, let's set some polling frequency. I will say 10 seconds. And then, guys, these two properties also very important. Let me explain them. What is that? Database rows per XML document. Database rows per XML document. This is one property. Next property is database rows per transaction. Database rows per transaction. Okay. So guys, these two are very important properties, and you need to understand how these two properties behaves. Okay. When we are trying to read the data from a table may contain 10 records, 100 records, 10,000 records, 1 lakh records, 1 crore records, correct? There is no limit. Okay, so we may have crores of records in our table. Okay, but when you deploy your SOA program with a DBAdapter polling operation, if your adapter try to read the entire data, it is not possible to process the huge data by using our SOA adapter and SOA program. Okay, so while reading the data from the table, we have to make sure we are reading small parts of the table. We are not allowed to read the entire table. Is it clear? We are not allowed to read the entire table. So now what I want to do, I want to divide my table into transactions. See, table divided into transactions. Okay, so that means one table can have multiple transactions. Okay, each transaction will have multiple documents. Each table will have multiple documents. I mean, we are simply dividing our table into parts. That's it. We are dividing our table into subparts. Is it clear, sir? Table, I mean, your adapter consider table as subparts, which we are calling as transaction, and transaction as subparts, which we are calling as XML document. Let's see that. Okay. So now that depends. This division, table divided into transactions, and how many records we are expecting in one transaction, how many records we are expecting in one XML document, that will be decided based on these two properties. Let's assume my transaction contains 10 records. Okay, and the XML document contains 3 records. Just an example, this configuration is completely customizable configuration. It's not predefined according to your table size and your data size. I mean, when I say table size and data size, guys, see, all tables are not same. I have a database table with 10 columns. I may have a database table with 100 columns. I may have a database table with 200 columns. Correct. So if you pick one record in a table where the table contain only 10 columns, okay, the record size is different. And where you pick one record from a table where the table contain 100 fields, the record size is different. Okay, two tables with a different number of columns, 10 columns and 100 columns. If you pick one record, they are not same. They have different size content, right? The size of the record is different because 10 fields and 100 fields. So while you are configuring these two properties, it is completely customizable, and you need to according to your table, you need to configure these two properties. Okay, so now what happened? If you observe our table, let me, oh, okay, uh, we did not completed the wizard, right? So let me say my table actually contains 22 records, 22 or 23 records. Okay, what is our source table? Our source table is student info. In this source table, I saw last time, I saw just beginning of the session today, in the beginning of our session, I saw that there are 22 or 21 records around. Now what happened? I want to divide this table into transactions and XML documents. See, my transaction size is 10. That means if you see this count, if you divided into subparts as 10, what happened? Three parts will be divided: 10, 10, and 2. Correct? If it is 20, if we have 22 records, that will be divided into 3 parts, 3 transactions. So first transaction, second transaction, third transaction. Again, transaction, I want to divide it into XML documents. So under this 10, if I divided it into XML document, and my XML document size is 3 records. 3 records. Okay. So then what happened? So this will be divided into 3. First XML document, second XML document, third XML document, fourth XML document. Hope you understand the equation. Okay. Same thing happened on the next transaction as well. 3, 3, 3, and 1. Okay, that means the first transaction contains 4 XML documents, second transaction contains 4 XML documents, and the third transaction contains only 1 XML document with 2 records. This is how, I mean, if we apply this logic, if we apply this combination, 3 and 10, our table contains 22 records, and the 22 records divided into these many parts. So this is one SOA instance, guys. Each XML document will be processed individually. Okay, so I mean, in one instance, or one attempt, it is going to process 3 records. Of course, that number you can modify. You can do some while doing practice. You can change these numbers and see how it is behaving. So everybody understand the calculation, how these two properties works?
Yes, sir.
Any questions? Yeah. So we are trying to divide the table. We cannot process the entire table in one step. So we want to have a logical division here. We are trying to make subparts of the table and we are trying to process it. Okay. Right. Come to here. So what is the size we thought? Database rows per transaction, I said 10. Database rows per XML document is 3. Then order by. It's your choice, guys. Again, it is optional. You want to read the records in an order, or you don't want any order. That's your choice. Let's say I want to use student ID as order by class. Now observe your SQL statement updated. Just see. Let me go to see this. Your SQL statement updated. See this. It included order by class. Okay, in an ascending order, it is trying to read the records now. See, this is the old query. Once I selected the order by class, this part is enhanced. Okay, your query updated. Done. So now what I want to do next, go next. If you want to change the query, anything you want to customize in your query, guys, when you are reading the data, you can add here. But as of now, nothing I'm doing. Just simply go to next. Next. That's it. Now we are not going to modify any of these properties. Simply say finish. Now observe, we got a new adapter. This adapter contains JCA file, mappings.xml, properties.xml, and an XSD file. All created. Okay, you can see the XSD file, student collection, table. This is the table structure if you observe. Okay, so this is the structure of each record: student ID, student name, English marks, Hindi marks, mathematics. Okay, done. Save everything. Save everything. Done. So our adapter is ready. Let's configure the Bpel process. Okay, this time I don't want any service component because I already have a service component in my composite. So I don't want to create a REST web service or HTTP web service or SOAP web service. Okay, this is fine. Let me calculate. Let me give some name to this Bpel process. Student grade calculator Bpel. Okay, say okay. Simply now create a wire. Go to Bpel. Use the receive activity. You can use a receive activity to accept the request. It's a regular configuration what we are doing in the other examples. Okay, create instance. I want to create a variable. Let's give a naming convention. I will say input variable. Okay, done. So now what this is doing, this guy will receive the input data. This guy receives the input data. Okay, what I want to test my program till this point and continue further. Okay, first let me deploy the code and test it. So guys, if I deploy this service, immediately it will start polling from the source table. I already told you, right, our source table contained around 21 or 22 records. Let me check that once again. Go to the database table, student info, run this, see how many records were there. Around 22 records. Okay, so 22 records were there, and if you deploy this code, immediately it will read the data. First, it will logically divide the table into transactions and XML documents. Each XML document will be processed individually. Okay, and once it read the data, it is going to delete the data from the table. That means all this data will be deleted. Let's see how it behaves. Deploy our code. Okay, deployment finished. Let's go to SOA service and enterprise manager. And meantime, I think the data, let's see the table, data in the table. See this? There is no data in the table. That means your service read the data. Once it read the data, it deleted everything. Okay. Right. Now go to your SOA instance. See how the instance created. You need to observe this, guys. If you don't observe the instance, you don't understand what is the pattern it follow out to read the data. See total how many instances created? 3 instances. Observe. As per our calculation, transaction 1, transaction 2, transaction 3. I mean here. Transaction 1 we are expecting 10 records. Transaction 2 expecting 10 records. Transaction 3 expecting 2 records. Let's see. So this is the first transaction, right? Let me open. If you open the first transaction, within the transaction, observe how many XML document processed. 1, 2, 3, 4. So transaction divided into XML documents. First transaction divided into XML documents. Okay. How many XML documents? 4 XML documents. See this? 1, 2, 3, 4 XML documents. Open one by one. If I open the first XML document, observe what it receives. It receives 3 records because our XML document size is 3 records. XML document size is 3 records. Every 3 records processed individually. Okay. So this is the first XML document. And if you go to the last one, it contains, last one contains only 1 record because out of 10, first XML document 3 records, second XML document contains 3 records, third XML document contains 3 records, and the remaining records are only 1 record. So that's what, if you see the last one, it contains only 1 record. It contains only 1 record, and it is processed in a ascending order, student ID ascending order way. See this 110. Okay. You can observe each instance, open each instance. Is it processing? Is it meeting all the parameters or not? You can check. See 104, 105, 106. We are reading it in an ascending order. So guys, if you don't select the order by class, it won't read it in ascending order. It will randomly pick the records. Okay. I mean, yeah, DBAdapter will pick randomly records from the table and process them. But it will not deviate this combination. So this is your total size of the table. And then it is dividing table into transactions. Each transaction processed as one instance. Under one instance, each document will be processed as an individual segment. Okay. See here, that's what we saw in this screen. Okay, each document processed individually. Okay, each document in the sense the document size what we provided here, XML document size. Okay, done. This is the first transaction. Let's see the last transaction. Last transaction we are expecting only 2 records, right? Let's go to the last transaction. This is the most recent transaction. If you open it, it is taking time. Suddenly it will become slow and takes time to open the instance. Okay, now, yeah. So now you see the last transaction, the third transaction contain only 2 records. So only one XML document enough here. One XML document with 2 records. See this instance, only one XML document. This contain only 2 records. This contain only 2 records, 121, 122. There are no other records. Okay. That's it. This is how a DB polling operation will work, guys. Let me complete the example. So what we want to do, once we read the data, I want to insert the data into a target table. So to insert the data, we already know how to insert the data, right? Let me go to DBAdapter. This time I will say student grade, insert something, some naming convention. Click next. So this is, we have the name handy. Yeah, copy the JNDI name, paste it here, click next. This time I want to perform insert or update operation. Insert or update operation, just say next. Import the table. What is our table name? Our table name is student result. Okay, done. Now click next. Let's assume there is no primary key in the table, so I'm assuming student ID as my primary key. Click next. No relational tables, and I want to insert the data in all these fields. I want to insert the data by using my program. Click next. Done. Nothing else you need to do. Simply go with the default configuration, create a binding or the wire, open it. See, this is the insert adapter. How you can call any reference component? That is by using invoke action. Okay, so in this invoke action, it's an insert operation, so we don't have output variable. Okay, only input variable. I will say invoke stu grade input variable. Done. I also provide a naming convention here, student grade. Okay, done. So our invoke activity is ready. So in between receive and invoke activity, I want to insert a new activity called transformation. Okay, I want to use a transform activity. Transform activity, perform the required data calculations. The source variable is our input variable. Target variable is invoke input variable. Okay, so you can give a proper naming convention for your XSL file. I will say calculate student grade, some naming convention. Say okay. Now you need to do the required transformation in this file. It's very clear our source contain multiple records. So we need a for loop here. We need a for loop. Let me add a for loop. Okay, create a mapping with the for loop. So now we started a loop. Copy student ID, student name, and then we want total marks. So how to get the total marks? Uh, so there is the first approach is you can add three subject marks. Okay, I will show you a different approach as well. First, let's see this mathematic functions. Okay, you can use my add function. You can use two add functions. I shown you in the previous example as well. You can use two add functions. Okay, so let me do the mapping here. Total marks, and then one more add function. Let's map this here. Done. And then English, Hindi, and the third subject I will add it to second edition icon. Done. So total 3 marks I added. This is a straight mapping. Otherwise, there is another way you can do, because the total marks I want to use to calculate the grade. Okay, to calculate the grade, I want total marks. For that, what I will do, I want to keep this total marks in a variable, a special variable, not a regular elements. Okay, I want to keep it in a variable. What I want to do, let's delete this. Okay, see, within the for loop, inside for loop, I want to create a variable, an additional variable. Okay, I want to create an extra variable. I will name it as total. I will use capital letters. Total underscore marks. See, this is an alternative approach. Okay, guys. I'm just creating one additional variable in my XSL file. The name of the variable is total marks. Say okay. See this. This is inside for loop. Okay, this is inside for loop. Let me do the addition. Total marks. Okay, and then second edition. Map it. Okay, English. Hindi, and then the third subject. This third subject, I am adding it to second edition symbol. Second edition symbol. Done. Now what happened? The total marks I am calculating and storing into a temporary variable. It's a temporary variable. Okay. I mean, it's a local variable to this for each, because it is created inside for each. You can also see this if you go to source, you can see the variable definition. See the variable definition inside for each. You can see the variable definition, and we are adding three subjects: English plus Hindi plus Maths. Okay. Now what I want to do, the same total marks I want to keep in my total marks field. The same total marks I want to keep it in my total marks field. So for that, what you can do, see this guys here, something called variables. The same variable displayed here. The same variable displayed here. You can map it. Then the advantage of variable is, if you have some logic which you want to reuse, you can copy the result of the logic into variables, and the variable you can use multiple places. See, this is the first place I used. I calculated total marks and stored into one variable. This variable I want to use at multiple places. The first place is this one. I want to copy into my target XML total marks field. Okay, this is first use. I want to use the same total marks in another place. I will show you. Grade, I want to decide the grade. How I want to decide the grade? According to the total marks. If total marks greater than 200, grade is A. If total marks between 100 and 200, I want to take the grade as B. Okay, if the total marks is less than 100, I want to take the grade as C. So I have dependency on total marks. So I don't want to calculate the total marks two times. I just want to calculate the total marks only one time. I store the result in a variable, use the variable multiple places wherever you want. Okay, and anyway, to calculate the grade, I want to use a conditional logic. Conditional logic. See, it is in the Bpel process. If you want to do some conditional logic, we used if activity, if else if activity, correct? But it is in the XSL. In XSL, we have something called choose when. We have something called choose when. Let me select the choose. This is exactly works same like your if else. Okay, click on choose. Now you see we are applying choose branch. Choose, which contains when. When is a conditional branch. When is a conditional branch. Of course, you can implement any number of conditional branches. So what I want to do, second, let me implement the second when branch. Second when. My choose contains second when as well. See, when condition meets, what is the grade? When second condition meets, what is the grade? You can set that way. You can add any number of when branches here. Okay, if you want, you can add one more when branch as well. So the third one I want to use otherwise branch. Third one I want to use as otherwise branch. Done. So otherwise branch is something like your else branch. Okay, this is else if. When branch behaves like your else if, otherwise behaves like your else branch. Okay, there is no condition required. Suppose above conditions are false. If all above conditions are false, automatically otherwise will be executed. Okay, so what is the first condition, sir? Our total marks must be greater than 200. Okay, you can see here logical functions. Here you can find a greater than or equal to function. Just drag drop it. Okay, you can see greater than the last one. Little bit screen got cut on the screen, right? So just drag drop this function here. So map it to your first when condition. See, first when condition. So what is the condition here? If the total marks, okay, if the total marks greater than or equal to, the second parameter is a hard-coded integer. Just double click on the function. Total marks greater than or equal to 200. I want to make it 200. Okay, then if it is greater than or equal to 200, control this condition is true, and the grade is A grade. I want to hard code the data here. Hard code the data. Give a text. Grade. I want to hard code this. Edit text value. Once you select the edit text value, you can give what do you want to say? I want to say grade A. Grade A. That's it. Done. First condition is ready. Similarly, you need to design the second condition. What is second condition? Greater than 100. Total marks greater than 100 and less than 200. Total 3 operators here. Observe what I'm saying. Total marks greater than or equal to 100 and total marks less than 200. So there are total 3 operators we are using: greater than or equal to, and operator, less than operator. 3 operators we need to use. So make sure how you are designing this. So first one, let's say, let's pick one operator. I'm using greater than operator. So greater than or equal to 100, less than or equal to 200, and then end operator. Okay, let's start with end operator. That's the easiest way. End operator. Drag drop the end operator. The result of end operator I want to store in this when operator. When done. Now one is greater than operator. Keep it inside the scope. Keep it inside the scope. Greater than or equal to total marks. Greater than or equal to. Okay. The result of this greater than, keep it in the end operator. Done. Now how much? Greater than or equal to how much? 100. So the first condition is ready. Greater than or equal to 100. First condition is ready. The second condition, less than operator. Just drag drop the less than operator within the brace. Within the scope. Total marks. And the result of this less than operator goes to end operator as a second parameter. Done. So how many? Less than 200. Less than 200. Done. So greater than or equal to 200 and less than or equal to 200. The result, final result, goes to your when condition. When condition. See, this is how you can design complex logic. Okay. Of course, you can do whatever condition you made here. You can also do it in the source view. You'll see that. Now go to grade. Done. Sorry, this grade. What we want to do? Grade. I want to calculate it as a B grade. If this condition is true, if the second when condition is true, my grade becomes B. I just want to hard code the grade. Done. If condition 1 is false, condition 2 is false, there is no need to check the condition 3, and I want to set the grade as C. Done. Okay, save everything. If you want, you can go to source view once. You can go to source view and you can check this. See, this is the choose when condition. Total marks greater than 200. Set the grade as A. Set the grade as A. If total marks is in between 100 and 200, set the grade as B. If the total marks otherwise grade as C. Okay, this is how we set the logic in the SSLT. Done. Save everything. Our Bpel is ready. Now you can deploy and test your program. So guys, if I deploy this program, it will try to read the data from the source table. Unfortunately, there is no data in the table because in the last attempt, the entire data was processed by our DBAdapter and deleted from the table, correct? So there is no data. So what I will do, either you insert the data, either manually insert the data here, or if you execute practice adapters example. If you execute our practice adapters example, what happened? Our practice adapter example insert the data into this table, correct? Yes or no? So either you can insert the data manually into the table, in the source table, or execute the practice adapters example. That guy read the data from a file and insert the data into the table. Okay, let me do that. How many records we have here? Okay, there are around 22 records. Okay, 23, 24, 25. So total 125 records. So according to this calculation, according to these two properties, okay, so total 3 transactions will be created. exactly same like this, but the last one will be changed. This becomes the last transaction contained 5 records, and this contained 2 XML documents, 3 and 2. Correct? This is the change, because with 125 records, this is how it will be processed. Let me place the file in the inbound folder. Let me place the file into inbound folder. You can give a naming convention, student 2208. Some name is fine. I mean, the name should starts with stu, otherwise it will not read. Just place the file here. So the first program, practice adapters program, read the file from inbound folder and write the file into outbound folder and insert the data into table. Second program, read the data from the table. I think it's already processed. You cannot see the data in the table, if I'm not wrong. See, it's already processed from the table as well. Just see the instances. Observe the instance. Okay, observe here what happened. First I placed the file. When I place the file, practice adapters, it's already running. It's a self-start program. I don't need to test it from SOAP UI like any other web service. So it's a self-start program. I placed the file in the folder. Immediately this guy picks up the file and inserts the data into table. From the table, calculate student grade project, start processing the data transaction by transaction. Each transaction, one transaction is one instance, and inside transaction will be divided into XML documents, each XML document processed individually. So the last transaction, if you take the last transaction, as per our calculation, the last transaction contained 5 records. That 5 records divided into 3 as one document, 2 as one document. So you can see 2 Bpel processes. The first one contained 3 records. Okay, first one contained 3 records. Second one contains 2 records. Sorry, I opened the wrong instance. Let me I clicked on wrong navigation. Anyway, let me open the instances. Okay, if you take the last transaction, the first XML document contains 3 records. Second XML document contains 2 records. 2 records. Okay. And what we are doing, we are trying to calculate the grade and total marks, right? Let's see the target table. This is our target table, student result. Check the target table. All 25 records must be here. All 25 records. See this, all 25 records are here with the total marks and grade. Total marks and grade. Any questions, guys? Any questions?
No, sir,
Okay,
clear.
Yeah. So this is how you need to work with DB polling and some little complex logic in the transformation. It's not really complex. We can do more complex logics, but I mean, as an example, I just want to show you some operations like how to use choose when, how to use a variable. These are all the things I want to show you in the exercise. Okay. Right. So that's it from my side. Let me stop the recording.